Bismillahirrahmanirrahim. Welcome students to the lecture number 2 of chapter number 1 exercise 1.1. We'll be covering the remaining articles of exercise 1.1. So by the end of this lesson you'll be able to solve exercise problems. But before proceeding towards our today's lecture, let's discuss what we have studied in our lecture number 1. We discussed functions. That is a relation between a set of inputs and a set of permissible outputs. An important part of understanding function is understanding their domain and range. Domain and range are the possible x values and y values of the functions. Then we discussed dependent and independent variables. Functions have dependent and independent variables. And when we use function notation, the independent variable is common x and the dependent variable is f of x. Then we discussed 4 different ways to represent a function. We have learned that we can represent a function algebraically or symbolically, numerically, graphically and verbally. Then we have solved exercise problems. We have done question number 1 and 2 of exercise 1.1. Today in this video, we'll be covering compound function, piecewise function, modulus function, composite function, and inverse of any function. So here are the objectives of our today's lecture. By the end of this lesson, you'll be able to evaluate the compound or piecewise function for the independent variables. You'll be able to know modulus or absolute value function and its graph. You'll be able to know one-to-one function and many-to-one function. You can recognize composite function and then to calculate algebraically the composition of two functions. And then finally to find inverse of functions. Now let's take start with our today's topic, that is compound or piecewise function. Now what is a compound function? Compound function or piecewise defined function is a function which is defined symbolically using 2 or more formulas. Here is an example of a compound function. A single equation may define the rate of pay for the day shift of a worker under certain condition. The condition given here is 7 a.m. to 3 p.m. Assume that the rate of pay for day shift is modeled by equation P of R equals to 8R, where R is the hourly rate. Another equation may define the rate of pay for the evening shift, that is from 3:30 p.m. to 10:30 p.m. The equation for this shift is P of R equals to 8 of R plus 50. We can combine these two equations to create a compound function. Now the two equations combinedly makes a compound function, that is P of R. Let's take another example of a compound function. Here is another example of a compound function. F of x represents a compound function which is the combination of two functions, that is x square minus 1 under this condition when x is less than 2 and 2x minus 1 when x is greater than or equal to 2. Now we have to choose our function according to our input. If the value of x is less than 2, we'll be choosing this function, and if the value of x is equal to or greater than 2, we'll be choosing this function. Now let's see visually how the compound function works. Now this function f of x is a piecewise defined function since f is defined using 2 formulas. This function is defined using these 2 formulas. To evaluate the function f at a number x, which is our input, we first determine whether x is less than 2 or not. If x is less than 2, then we use the first formula, that is x square minus 1, to evaluate the function f of x. For example, if as my input I'm taking x as minus 3, which is a negative number and it is less than 2, so I'll be choosing this formula to evaluate the functional value. So the formula chosen is x square minus 1, which is equal to 8. Now what if the value of x is greater than or equal to 2? then we'll be choosing the second formula, that is 2 minus x, to evaluate the functional value, that is f of x. For example, if we are taking our input as 7, so 7 is greater than 2, so you'll be choosing this formula to evaluate the functional value f of x. So after solution, your output will be minus 5. Now we want to draw the graph of this function f of x. Let us first draw the graph of the parabolic function, that is y equals to x square minus 1. This is the graph of a parabolic function, that is x square minus 1. But we are given with a condition of x. The input is less than 2. So we are restricted with the values of x. So we erase the part of graph for x greater than or equal to 2. So this much part of the graph will be left according to this condition, that is x less than 2. Now let's draw the graph of another function, that is 2 minus x. Since 2 minus x is a linear function, so its graph will always be a straight line. Now let's draw the graph of 2 minus x. Here is the graph of 2 minus x, since it is a straight line, but we are given with a condition. The condition of x, that we can only take the values of x as greater than or equal to 2. So for that, we erase the part of graph for x less than 2. So we will be left with only this much part of the graph. So this is the graph of function f of x, which is a compound or a piecewise defined function. Now the next topic is absolute value function. What is an absolute value function? The absolute value function is a piecewise defined function. It is defined using two formulas. Absolute value function is a perfect example of a compound function, that is f of x equals to minus x when x is less than 0 and x if x is greater than or equal to 0. Since this function is the combination of two functions, that is why we can also say that absolute value function is also a compound function. Here is the graph of the absolute value function. The graph will consist of portions of two lines with equations y equals to x and y equals to minus x. For x greater than or equal to 0, the graph is a line y equals to x. And for x less than 0, the graph is a line y equals to minus x. The two partial line meets at the origin. Now let's see how this absolute value function works visually. So here is the absolute value function, which is a piecewise defined function since it is defined using two formulas. To evaluate mod of x at a number x, we first determine whether x is less than 0 or not. If x is less than 0, then we use the first formula, that is minus x, to evaluate the mod of x. For example, let us take our input as minus 3. As minus 3 is less than 0, so we will be choosing this functional value. Minus sign is of formula, and then minus 3 is our input, which we have taken as x. So as a result, your output is positive 3. Since minus 3 is less than 0, if x is greater than 0, then use the second formula, that is this one. We will be using this formula when x is greater than or equal to 0 to find the mod of x. For example, let us take our input as 7, which is greater than 0. So we'll be choosing this functional value. Our output is positive, which is greater than 0. Now we want to draw the graph of absolute value function. Let us first draw the graph of a straight line, which is y equals to minus x. Here is the graph of a straight line, which is equal to y equals to minus x. Since we have the restriction with the values of x, and here the values of x for this function are less than 0, so we erase the part of the graph for x greater than or equal to 0. So this much part of the graph will be left. Now let's draw graph of another linear function, that is y equals to x. Here is the graph of a linear function y equals to x. Again, we are restricted with the condition. Since we have to take the values of x as greater than or equal to 0, so we erase this part of the graph which is for the values of x less than 0. So this much part of the graph will be left, and this is the graph of an absolute function. After taking the concept of compound and absolute value function, now let's move towards the new topic, that is one-to-one function. A function f of x is said to be one-to-one function if each range value corresponds to exactly one domain value. Otherwise, it is said to be many-to-one function if each range value corresponds to more than one domain value. Now let's see the one-to-one function visually. We have defined a function to be a rule or correspondence that associates to each number x in the set A a unique number f of x in the set B. We start with two sets A and B. A is called domain of f and B is the range of this function f. Let us see what it means to say that for each x in A, function f determines a unique number in B, which is called f of x. In this picture, f of x is associated with x, f of A is associated with A, and f of E is associated with E. That is, x is the input of this function, and as a result, your functional value will be f of x. A is the input, functional value will be f of A. E is the input of this third function, and the functional value will be f of E. So one input has one unique output, so we can say that this function is one-to-one function. What do we mean by a unique number f of x in B? It means that to any x in A, there cannot be more than one number in B associated to x. For example, this picture is not the picture of a function. Why? Because two numbers in B are associated to a number A. Finally, we note that a function can take two or more distinct numbers in A to the same number in B. In this picture, f of A is also equal to f of x. So, this function is many-to-one function. Previously, the previous graph, this was not a function and this function was one-to-one function. Now let's discuss, are the following functions are one-to-one or many-to-one functions? Now let's discuss them one by one. This given function is many-to-one function since the value of y, which is equal to 4, corresponds to two values of x, that is 2 and minus 2. Now the second function, which is y equals to x cubed. This given function is one-to-one function since the value of y, which is equal to 8, corresponds to exactly one value of x, which is 2. Let's discuss this third function. Oh, this is an equation. This is not a function. Why? Because two values of y corresponds to one value of x. How can you get the same value of x when you are inserting two different inputs? So this is not a function.